Welcome back, learners. In the previous class, we were discussing about the application of the loads on the slabs. That is nothing but the application or the assigning the loads on the shell. So, in the shells, again, we have discussed about the loads if you want to apply the uniform load, or the loads if you want to apply of the non-uniform, as well as if you want to apply any temperature variation loads, right? Similarly, let us see that the applications of the loads on the frames. Now, when I say the application of the load on the frame, again you have different conditions. Okay, so first, before that, what I will do is, let me consider one frame here. So let me consider this beam. Okay, so let us understand the concepts of application of the loads on the frames on this beam first before we apply the loads on the entire building. Okay, so I'll go to assign. So since I'm applying on the beam, definitely it is a frame, so I have to go to the frame. Now, when it comes to the application of the loads, you have different types of loadings. Like it may be a point load, that is, or we can also call that as a concentrated load. Then you may also have along with the point load, you may have the uniformly distributed load. Okay, we call it as UDL, uniformly distributed load, or also you may have the uniformly varying load, we also call it as UVL. Then even we may apply the moment, or we may apply the couple at any point whatever is required. So now let us go one by one. So now when I want to apply the load, that is a point load, that is concentrated load. Okay, so again you can see that, there also, if you see now, I can have an option to apply the loads anywhere on this beam, either at the center or other than at the center, anything is okay. Now again, first let me apply the dead load, or if you want to make it as live, you can make it as live load. So that is, choice is left to us, because since in this project we have considered only two load patterns, we will be having only dead and live. So either you can choose dead or you can choose live. Again, you have, if you want to apply forces, you can apply forces. If you want to apply moments, you can apply moments. So again, two options. So let us see about the forces. Then again, once you decide what type of load you want, whether you want force or moment, then you have an option to choose the direction of the load. Okay, so definitely all the loads will be considered gravity if it is a dead and live. If it is a dead load, definitely it has to be considered in the direction of the gravity. But if it is a live load, then it may be other than the gravity direction. And definitely if it is a lateral load like wind load or the earthquake load, definitely it will not be along gravity. It will be gravity also, other than that it may be in other direction also. So based on the type of loading, we are supposed to choose the direction. So here let us assume that the live load is also acting along the gravity. And as usual, if you want to have applied one load, if you want to replace that, you can use this option. For that, if you want to add something, you can use this option. And if you want to delete, you can delete it. Right, now you can see that the point loads I have given. Okay, you can see that there is a distance as well as there is a load. Okay, now first you have to understand that they have given 4 coordinates, 1 2 3 4. They have taken, see, you can see a relative distance from end I. Okay, relative distance from end I, that means when I choose this, it will take this as I. Okay, and it will take this joint as one more joint. For example, let me click and right click on this. Okay, you can see that here nothing can be seen here, only the unique names, everything will be seen. So geometry, you can see now when you go to the geometry, so end I, that is joint 16. Okay, you can see that this is joint 16. If you want, I will show you. You can see it is a joint 16. Okay, and this will be 17. Okay, now you can see here, so end I joint 16 end J, joint 11. Okay, yes. So now you can see that now if you want to apply the load, okay, if you want to apply the load, so frame load, point load, you can see that when I choose the relative distance from I, so it will start from I here, okay, so then it will start from J here. This will be I, this will be J. What is this difference between relative distance and absolute distance? I'll tell you. Now when I want to apply any load here, then you are supposed to choose the distance 0, okay, and make the load as, like for example, you want to apply 5, okay, you want to apply 5, okay, make it as 5, and you just see that it is force under gravity, you just apply it, okay. Now you can see that everything is applied, okay, it is applied to the entire structure, okay, it is applied to the entire structure, okay. But since it has been taken in the direction of the dead load, it has been applied like this. I'll show you, because dead load means it will be definitely, it will be considered like this. Already the dead load has been applied here, okay, yes. So for that, what we will do, first we will delete the dead load that what we have applied, okay. So let us go to the select, so or what we will do is, we will go to the assign, we will go to the frame loads, we will go to the distributed, so in that already dead is there, okay, so already dead is there, so let us make it as 0, okay. Or what we will do, in before that we have to select, okay, select the properties, that is the frame sections, so I have to choose these beams, beam, okay, all these beam I have selected now, okay, so all these beam I have selected, right. So now assign, go to load, it was a distributed, I will tell you how it has been done, okay. So you make it 0, so now it is 0 now. Now go to this load, only I need it on this, because in order to understand the concept I will select this beam, so go to assign, okay, go to frame load, in that point, okay, I told you at a distance, okay, at a distance 0, that means I need it at here, you apply it, okay. So it will not show, you can see here the load has been applied here, okay, you can see that there is a point here, the load has been applied, that means this is my point I, okay, this is my point J, your load 5 has been applied, you can see here, you can make it to 10 also, you can see that now it has been made it to 10, or if you want you can make it to 25 also, okay. One second, it is 10, okay, or you can make it to 25. So that means okay, so that means this is your point I. So since I have given the distance 0, so this is coming like this. Now in case if you want to make this as 0, okay, that can also be done. Now you don't want any load to be applied here, make it 0, apply it, okay, again, so you delete this, okay, yes, everything is deleted. Now instead of at 0, if you want to apply any load at 0.25, then you give 10. Now you can see that at this distance, that is 0.25, it is indicating, means that is 1/4 of the distance of your beam. Like for example, if your beam is of for example 9 meters, so if I am applying the load at the first point, that is at the point at I here, then your distance will be 0, you can apply the load, okay. Then if you want to apply it at a distance of 3 meter, that means 1/4, you have to apply at 0.25, Okay, or if you want, you can change also. You can say you can make it as 25. That is also not an issue, right? Okay, I don't want here also, you can delete it. Okay, I don't want here also, you can delete it, right? Then if you want to apply at 0.75, okay, so then there also you can apply 25. Select this, you can see that it is applied here. Okay, right? So if you don't want there, you delete it, nothing wrong, 0. Or if you want it here now, that is at this point, so then you have to go to this 1. Okay, so there you can apply 25. You can see that it is applied. So like that, wherever you want, you can apply. Or if you want it at all these distance, for example, if you want at this all these distance, then you can give 5, 10, 15, 25, like that. You just give apply. You can see that the loads is applied 5, 10, 15, 25. It is done. So like this, however you want, wherever you want, you can apply the loads. Okay. In case if you want it exactly at the middle, okay, so you can vary these coefficients also. What you do, you just make the coefficient as 0.5 and give the value as 20. Okay, so give it as apply. You can see that it is going to act exactly at the center of the beam. Okay, so like this, either it may be dead or it may be live, whatever it may be, wherever you want, you can add the load from these combinations. So if you want to add something to that, you can go to the existing, add to the existing and make it on 10, for example. So the 20 will be there. When you add it, it becomes 30. So like that. Okay, so this is all about forces. Now in case if you want to apply about the moments, so what you can do, go to assign, so go to frame loads, again points. Now instead of forces, I'll go to the moments, the same concepts, but you are going to apply the moment values. Okay, like for example, here I'll make it as 0, here I'll make it as 0.5. Example, apply. You can see that the moment is applied. Okay, there is a difference. The moment is applied, it is shown like this. Okay, in the ETABS, the moment is shown like this, the arrow is shown like in the another way. Okay, so there is a difference. Okay, yes, like this. In case if you want, I can show arrow will be shown like this. I will make it as 0.30, I will make it as 10 and I will make it as force. Okay, so that you can get the difference. No, it will not be showing. Okay, no issues. Okay, so moments. Okay, so like this. So wherever you want, you can apply the moments. Okay, so this is about the application of the point loads. Now in case if you want the uniformly distributed load or if you want the uniformly varying load, what you are supposed to do? Select this, then go to assign, go to frame loads, then from point you go to distributed. So in the distributed, again the same options you will get. Either you can apply the load for the dead or you can apply the load for the live. And again, whether you want to replace or you want to add or you want to delete, that is also there. Along with that, either you want force or the moment, that is also there, or even the direction is also there. Now when it comes to the distributed, we have mainly two types of loading acting here. One, we call it as uniformly distributed load. That means for every distance, for every each 1 meter or 1 unit distance, your intensity of the loading is going to remain same. For example, if I want to say it in feet, right, you have a 10 feet beam, so for every 1 feet the intensity loading is going to remain same. So then we call that as uniformly distributed load. In case for every 1 feet, if its value intensity of the loading is changing, means then it becomes the uniformly varying load. Now if you want to apply with respect to uniformly uniformly distributed load, then this tabular column will not come into picture. The uniformly distributed load will be called as uniform load, whereas uniformly varying load will be called as trapezoidal load. So if you want to do with respect to uniformly distributed load, this entire row will not come into picture. I will explain that. Because in the uniformly distributed load, there will not be any distance. If you are applying for the entire beam or the entire column or the entire member. So therefore I have chosen this beam. So just give the value of load whatever you want, that is uniformly distributed load. Just give apply, it will be applied like this. You can see that 15 kips per feet it is applied. Okay, or if you want to change to something, you can change it by 20 also, like this. So for this is the only row that you are using. This directly give the loads and apply it. Okay, that is very simple. That is uniformly distributed load. Now in case if I want to go for the uniformly varying load, then definitely the lot of combinations will come. Okay, I will show you one by one. Right, I will show you one by one. When it comes to uniformly varying load, the lot of combinations will come, as I already told. So the first combination that you can have is like this. Okay, the first combination that you can have, I can show like this. Okay, so this is the first combination you are going to get. Okay, and your arrow will be shown here like this, so in this direction. Okay, so that means at one point the intensity is 0 here, and at another point the intensity is something like 10 or 15, whatever the value. This is one type. The second type that you can expect here is, second type is this here, okay, and here. Okay, so this is second type. Okay, this is second type. So that means here also there will be some loading, here also there will be some loading, but its intensity is changing. Okay, so that is one. Or even you can have this type of loading also. Okay, you can expect like this. So this is one more type of varying load. Okay, so this is one more type of varying load. So like this you can apply anything on here. It will be 0 here, 0 here, but you will be having maximum load here. Now if I want to explain that way, in that way, let us try to see now. Now when I take the first one here, you can see that here it is 0, here it is maximum, correct? Okay, so that is the case, means now if I'm choosing relative distance, means this is the point where my load intensity is going to start. So let us make this as 0 and let us make this as highest one. Okay, so that means the distance at 0, the load will be 0. Okay, whereas these things you have to actually explain them, or else what we can do, you can keep it as it is, and at 1 you can show that the value is going to be 20. Okay, let us see that how it is going to be. You can see that it is going to like this. Okay, so since it is 0, okay, or let me do one thing, I will take up another beam so that it will be clear. Somewhere here I will take, yeah, let me take this beam. Okay, assign, so frame load distributed. Now 0 I kept the value 0, here I kept it 20. So if I apply, now what happened is, you can see that it will not start from 0. Okay, so it is anyhow it is 0 only, but here it has taken 20. Okay, so it has went like this, it has taken 40. Or what you do is just go back, select this, you go to absolute distance, then okay, then you make it the value 1, apply, right? So now what will happen is, here in order to do that, we should know the distance. If I give 1 means it will take at a distance of 1. So therefore better is what you do, click on this, just get the value of this beam. What is this? 5 feet, correct? Okay, so now what you make is, so 0, 0, so at the 5 you make it 20. Okay, at the 5 you make it 20. Okay, you can see. Or what you do is, now you make it as the relative distance. So this one, okay, let's see what is going to happen. This is also 0, so this, let us make it as 5. Okay, so they have given relative distance. Okay, so then you make it 1 and you apply. Yes, now it has been done. Okay, so like this, what you can do, you can do the application of the loads. Or what you do is, you do one thing, this may you make it as 0, 0. Okay, you select this, and this you make it as 1 and 20. Okay, or if you make it absolute distance, let me make it as live now, then let me check, delete. Okay, it is deleted. Force. Okay, this I have to make it 0, correct? Now it will come. 1 second. Yes, I selected this, I made it as live. This is 0, so let me keep it as relative distance only. So this let me as 0, this let me keep it as 20, and I'll apply. So now it is coming 0, 20 here. Okay, okay, so that means I have to give the value. Clear? That means what I have to do is, at 0 it is 0, at 0.25 you give it as 5, at 0.75 you give it as 10, and at 1 you give it as 15. And now you apply it. You can see that however you want, it will be varied. Okay, however you want, it will be varied. So like this you can do this. If you want to do this one, then what you are supposed to do is, here it is not 0, here also what you do, you just remove this. Okay, so here it will be some 5 at 0, then 0.25 you make it as 10, so 0.75 15, then this you make it as 20. Apply it. So now you can see that from here only. So or if you want, you can have a higher value, 25 here, 30 here, 35 here, 40 here. Okay, it was not selected. Yeah, yes, so now you can see like this. So if you want to show the third one, then 0 here, 0 here, only middle is maximum, correct? Only middle is maximum. So what you can do? Simple. You make 3 columns, this you make it as 0, this also you make it as 0. Okay, right? Select this. So what you do? 0, make it 0, 1, make it 0, then 0.5, make it 30. Apply. You can see that it is applied. Simple. Okay, so you can use this anything, 0, 0 here, then exactly at the middle 0.5, 30, then again at 1, 0, 0. Okay, this you have understood. If you want to show this exactly, you make it into 3 columns, 2 columns only, here and here. Okay, I'll show you what to do. Right, you just select this, go to only 2 columns. This also you make it 0 0. Now initially at 0 the value you can give it as 20. Okay, and at 1 you can give it as 50. Apply it. You can see now this is applied here to here 50. Now this is also done. So now if you want to show this, then very simple, select this. Okay, select this beam. So 0, it will be 0. At 1 you can give 50, apply it, it is 0 to 50, it is applied. So like this it can be done for the forces as well as for the moments also, even as well as for the dead end line. So this is about assigning the frame loads. Okay, and finally the temperature also, like how we have done for the shells, in the same manner it can be done for the temperature. In detail we will learn this when we go to the next project. Okay, so let us continue this about assigning option in the next video. Thank you, learners.